Welcome, boys and girls, to day 2 of Unit 5. In this lesson, we're going to find the number of solutions. We're going to talk a little bit about imaginary solutions and how to write a polynomial if given its imaginary solutions and irrational solutions. Let's begin with a couple of notes. A polynomial may have imaginary solutions. Imaginary solutions will not intersect the x-axis. Only real solutions intersect the x-axis. When graphed. So we can't find imaginary solutions by graphing. The total number of solutions must equal the degree, and we talked about that a little bit yesterday, the degree of the polynomial. And imaginary solutions, and I'm going to say imaginary solutions and irrational solutions must come in pairs. So in other words, if a solution is x to the 3i, then it also has to have a solution x is negative 3i. If we have a solution x is radical 2, then we also have to have the solution x is negative radical 2. Okay? So let's explore that. So the number of roots possible must equal the number of real roots plus the number of imaginary roots, with the exception of multiplicity, which we're going to talk about in a second. Okay, so yesterday we talked about this is a quadratic function. Its degree is 2, so the maximum number of roots is 2. When we graph this on the calculator, we see that it never crosses the x-axis, so it has 0 real roots. Well, it has to have at least the maximum number of roots is 2, so if it has 0 real roots, then that means it must have 2 imaginary roots. Okay, the number of imaginary roots will always be even, an even number. Okay, if we look at the next equation, the next function, this is x cubed. So the maximum number of roots it could have is 3. When we see where it crosses the x-axis, we see that we only see it cross the x-axis once. So it has 1 real root. So how many imaginary roots will it have? So because it has only 1 real root, then it will have 2 imaginary roots, because 2 plus 1 equals 3. Now this next one's a little tricky. It is a third degree polynomial, so the number of maximum possible roots is 3. And we see that it has 2 real roots. So how many imaginary roots does it have? Well, it can't have just one, because we need this to be 1. It can't have 1 imaginary root, because imaginary roots come in pairs. So it can't have 1, so that means that it has no imaginary roots. Okay, because it can't have just 1, and if it had 2, then it would have 4 roots, and it would violate this principle. So how is this? This has something we call multiplicity, meaning one of its roots occurs twice, and the root that occurs twice is this one because it bounces off the graph. And we're going to talk about this more in the coming days, but just know that this root is exhibiting multiplicity. So therefore this does not have any imaginary roots, but it has 2 real roots, and one of those roots has multiplicity, which we will talk about on Thursday, I think. Multiplicity, okay? Alrighty, and then if we look at the next one, it is 4th degree. How many real roots does it have? It has 2. So how many imaginary? 2, because 2 plus 2 is 4. And also, this has to be an even number. Okay, pause the video and you do the last two, and then we'll come back and talk about it. All right, welcome back. this is a second degree, so it's got to have 2. It has only 1, but it can't have an imaginary root because imaginary roots come in pairs, so it can't have 2. So once again, this has 1 root, and it had with multiplicity. And what gives away that it has multiplicity is the fact that it bounces off the curve here. This is the third degree, and in the graph we're given 2. So how many imaginary does it have? 0, because it can't, imaginary roots come in pairs. So again, it has 2 roots, 1 with multiplicity. Okay? Now we're going to look at, given the roots, how do we write the equation in standard form and in factored form? So there's a couple of things we need to remember. We need to remember that when we multiply radical A times radical A, that's A. When we multiply I times I, we get -1. Now, if this is something new to you, because I'm not sure if you guys have seen this before, but if it is, I'm going to put a video on Google Classroom so that you can go and watch a video on i's if you don't understand. But for now, I just need you to know that I times I is equal to -1. And imaginary and irrational roots come in what? Pairs. There will always be 2, 4, 6, 8 of them, never just 1 or 3. Alrighty, so we're going to be given the roots. We're going to write the polynomial in factored form and standard form. Okay? So this is a second degree polynomial, and it has, roots at radical 2 and negative radical 2. So writing this in factored form is not too bad. We get x minus radical 2, x plus radical 2. Now what you should notice about these are they are conjugates of each other. So when I have conjugates of each other, if I have x minus b times x plus b, what happens when I multiply them together, I get x squared minus b squared. The middle zeroes out, and I'm going to show that to you. So if I multiply x times x, I get x squared. If I multiply x times radical 2, I get plus radical 2. Negative radical 2 times x gives me negative radical 2x. And then radical 2 times radical 2, going back to this principle, that is just minus 2. So notice my insides zeroed out, and so I'm left with x squared minus 2. Okay? So I'm not going to do this again. Every time we see a conjugate, we just know we need to multiply the outside, the first and the last in a conjugate. All right, and so then this becomes the standard form of that polynomial. Okay, I kind of skipped this one because I think we did enough of those yesterday. So let's look at a second degree with root 3. So it's second degree, and it's only giving me 1 root. But I should know, because I was told that it was second degree. How do I make it second degree? I have to square the entire thing. And that's what we talk about. This has a multiplicity, because it looks as this 1 root is occurring twice. And so in standard form, if I were to multiply this out, x minus 3 times x minus 3, I get x squared minus 6x plus 9. I just want to do that with you right quick. So that's x squared minus 3x minus 3x, and then plus 9. These do not zero out because they're the same thing. So we have to combine those, and that's how we got -6. Sorry. So I have third degree, and I have 2 imaginary roots and a real root. So writing this in factored form will give me x plus I, x minus I, and x plus 2. Now, it is wise to multiply these together first. Okay? So it's easier to multiply your conjugates together first, because when I multiply them, I'm going to remember I multiply the first and the last. So I get x squared minus I. and minus I squared. And so from what we learned up here, I times I is -1. So this is going to be x minus -1, which make that x plus 1 times x plus 2. And then we would multiply that, so that's going to give me x cubed plus 2x squared plus x plus 2. Okay, so now we have a third degree. Oh yeah, I did multiply by the real root. Okay, so now we have third degree. It has 2 irrational roots and an integer root. So we're going to write this as x minus 1, x minus radical 3, x plus radical 3. Again, it's better to multiply the conjugates together first because they just do something pretty when you do that. So we're going to multiply those conjugates and we get x squared minus radical 3 times radical 3 is just 3. And then we multiply by x minus 1. So following that out, I get x squared, x cubed. I'm just one ball of cough here this morning. X cubed minus x squared minus 3x plus 3. That's in standard form. All right, one more. We have third degree. It has roots of 0 and radical 5. Remember, radical 5 has to come in pairs, so that means it has roots of 0, radical 5, and negative radical 5, because this has to come in pairs. So then I get x minus radical 5, x plus radical 5, and then x minus 0, which is just going to be x. Okay? So I multiplied these two together. Remember they're conjugates, so I just have to multiply the first and the last. And then x minus 0 can just be written as x. So this is x cubed minus 5x. Okay? All right. So your homework assignment is to practice this. And so I'm going to let you do your homework, and the answers are on Google Classroom. So complete the homework, and I will see you tomorrow. Remember that imaginary roots and irrational roots come in pairs. That's the big thing takeaway from this. Imaginary roots and rational roots